Welcome everyone to the ENGAGE webinar, Everyday Examples in Engineering. This is a discussion among mini grant winners. My name is Jane Langeman and I'm the facilitator of this web meeting. I'm going to turn it over to Pat Campbell to introduce our discussion leaders. Pat?
Thanks, Jane. As Jane said, I'm Pat Campbell. I'm the president of Campbell Kibler Associates and a co-PI in the ENGAGE project. I actually started my life in math and physics, but I'm now at this point an educational researcher and have been for many years. I was a professor of research measurement and statistics at Georgia State University, and I quit the day I got tenure, and they still talk about it. So I'll be here with you and Scott and Tonya. I'll tell you a little bit more about them later. They are fabulous. They're rock stars. Okay, so who's on the call today? Well, we all are. You are about half of the Everyday Examples in Engineering mini-grant winners. Congratulations. We had a webinar on Tuesday with the other half, and we're very excited about having you all here. So let me tell you a little bit about the mini-grant and the mini-grant winners. You come from all over the country. You come from private schools, you come from public schools, you come from technical schools, and the major thing you have in common is all of you are interested in using everyday examples with your students to kind of make things more relevant and motivating to them. So we'll talk more about that as we go along, but I wanted to do a little more of an introduction to Tonya and Scott. Tonya really is a rock star. She's an expert rock climber along with being a lecturer of engineering at Santa Clara University. Prior to that, she was a tenured associate professor at Cal State Chico. Tonya is a strong advocate for excellence in engineering education and has worked extensively with the American Society of Civil Engineers teaching workshops and the Committee on Faculty Development. She is, of course, a committed everyday example user. And Scott. Scott's an assistant professor of mechanical engineering at York College. Prior to that, he was an academic specialist in mechanical engineering at Michigan State University, where he received the Withrow Teaching Honor. And I love this description of him, so I'm going to read it to you. Scott's an exemplary teacher who always goes the distance for his students, who has the ability to present material in a way that's understandable to his students, clearly expressing his desire to facilitate their learning. Now, I would credit Everyday Examples for at least some of that. Okay, so let's do a quick look at why we're here today. The first thing we're going to do is to go over the mini-grant requirements, and if you have any questions about them, great. So as I said, we're going to go over the mini-grant requirements, and if you have any questions, it's a good time to ask them. You'll have a chance to speak with our two everyday example gurus and hear about some of their successes and challenges. We'll be happy to answer any questions you have about implementing the everyday examples. And also would love to hear your ideas and suggestions for how to implement everyday examples. And finally, let's talk about some ways that you may want to use to assess the effectiveness of everyday examples. One thing you need to know is you're not required to assess the effectiveness. But as we'll talk about later, particularly when you're talking with your colleagues, it's always really nice to have some of your own data that shows how it worked. So let me get started with the mini-grant overview. And then I promise you're going to get to hear more from the gurus than you do from me. So as you already know from the mini-grant, that the mini-grant period started last month, the beginning of March. The mini-grant started the beginning of March, and it will go until the end of March of 2014. Each of you got $2,000. And for that $2,000, there are 4 things that you've committed to do. One is to integrate at least 6 everyday examples into first or second year courses. A second is to attend this webinar and discussion, and we thank you for doing that, and congratulations, you filled one of your tasks already. A third is to present to your faculty in whatever ways you think are best about your experiences using everyday examples. And then finally, our evaluation team from the University of Washington will, during the course of the year and probably at the end of the year, send 2 short online surveys. And they're evaluation surveys for the National Science Foundation. And what we're doing is try to find out what everyday examples you used, how they worked, about how many students you worked with, and so on. Okay, so enough with the paperwork. Let's get down to everyday examples. Now, when Tonya and Scott and I were talking, Tonya and Scott came up with this quote about why they should use everyday examples with students. So why don't you two talk about where it came from?
I mean, I can start it. I think we were having a dialogue, and we were just noticing that if the students are familiar with the idea to start with, then they're more likely to be engaged and be interested in what you're talking about. If I come at them with some esoterical example that they've only maybe seen a picture of or haven't ever really experienced, the example doesn't mean a lot to them, and they don't really care about the answer.
Mm-hmm.
And the truth is, then you can do so much more once you have their attention. You can develop your theory further, you can do more complex examples because they're interested and they want to know the answers to the problems that you're talking about.
So what you're also saying is it doesn't just motivate them, but it gets them hooked into such a ways that you really can increase the complexity of the kind of theories and the kind of formulas and the kind of discussions that you're having. So this is probably a good time to talk a little bit about what everyday examples in engineering are and what they're not. These are some of our favorite examples, and including David, you'll be able to see, you'll recognize that dog shaking over there. Because some of the things that we know about everyday examples is it has to be familiar to the students, and it's got to be of interest to them. If it's not something that's interesting, you're not going to motivate them. They're not going to care. Practically, the everyday example has got to be relatively easy and cheap to set up. If it's a ton of work to get it, or if it's very expensive to buy things for it, then people aren't going to use it, and it's not worth it. One of the things that we often don't think about is that either mathematically or contextually, the example has to be tied to the concept that it's demonstrating. That sounds obvious, but it's really, really important. And normally it's short. You're talking about a class period or less, and you're really kind of using it to demonstrate what's going on, not to kind of take over the class. I don't know, Tonya and Scott, I know you both do design projects as well as everyday examples. Could you talk a little bit about what some of the differences are between design projects and everyday examples?
You know, right off the bat, everyday examples are really something that I like to include more in my lectures. You know, I'll take standard course material, and you just preface that with an everyday example. And you can go through it and do your lecture material and come up with the examples, and we're going to go through the stages of how that works. But you know, I use that, again, think of it as lecture material. And problem-based learning is great, and I love doing that also, but I think of that more as outside of my lecture material. You know, I think of that as an extra activity for them, whereas this I'm including with my lectures.
You know, it's interesting that you say that, because Krishna just made a comment where he said that those first 5 minutes of the start of class are crucial. And that's really when you all start introducing the everyday examples, in that critical 5 minutes.
Yeah, if you remember, on Tuesday, one of the participants actually called them the hook. And it was such a beautiful word for it. It's that hook to get them engaged. Right now I'm teaching the strength of materials class this quarter. Yesterday I introduced axial deformation. You know, and typically you'll have a drawing of a long bar with a bunch of arrows going different directions on it to show loading. And, well, why would an axial bar have a bunch of different loadings? Well, it was really easy to show a picture of a ladder with someone climbing it, and at each rung where there was a load that they were putting on it, that put the arrow on the stick. And we could go from the ladder to a picture like what we were solving, and suddenly they're like, oh, it's not just some stick with arrows. And it had a lot more meaning for them.
And your point about the picture is a good one, too. Sometimes you don't have to have the example there. A picture can almost do it. Tonya, perhaps you could give us a little more detail about when you're doing axial stress.
Well, this is Friday's class, so this will be tomorrow. But we talked about this in the webinar back in January, but this is one of my hands-down favorite E3s, simply because it has such impact on the students. And using the headset that I'm wearing now, I always play music at the beginning of the class, so the day that we're talking about how do you use axial deformation to solve statically indeterminate problems, specifically when you have a composite material, I just walk in listening to music instead of sharing. And they think that's silly, and I'm up prepping the room, and I'm rocking out, and they can't hear the music. And then, you just ask them, have they ever broken their headphones? Have they ever dropped their iPod or their iPhone? And did the cable hold it from falling on the ground, the fact that the cable is plugged in? And there's always someone who has. And then I have these little bags that happen to be on my desk right now that I've already pre-sorted that have an actual white wire that has the plastic coating and the wire inside, stripped wire, and then just the shrink tubing. And they're already sorted, so I can just hand a little pack to a row. They pass it back. They all take one of each. I ask the person in the back to keep the baggie. And then at the end of class, I tell them to pass them up and fill the baggies again, so it's super easy for me. And it's great because they pull on the shrink tubing and see how much it stretches. They pull on just the stripped wire and see how much it doesn't stretch. And then we say, well, how come when it's a composite, what happens? And they go, well, gosh, it stretches the same amount. Well, how can that be? And we're then able to really explore it as we see the 5 E's here on the slide. We're able to explore what's happening. We then actually derive the formulas to explain it, so it's great. We do the calculation. And then we can move into other examples. We talk here at bones, which is great. We have a lot of bioengineering students. We can look at different behaviors, and this is so much better than the typical textbook example of you've got a brass tube with a steel insert. Why do you have a brass tube with a steel insert? I have no idea what the application is for a brass tube with a steel insert. So I love this one.
Thanks, Tonya. And as you pointed out, now this is not the only way to do everyday examples, but one of the ways we have found that's been useful, and a lot of our examples do this, is the engage followed by exploring, explaining, elaborating, and then evaluating, the 5 E's. Now, Scott, I know you have a favorite everyday example that's somewhat more adventurous.
Mine was fun, and I like this one because it grew. My goal for this one was actually just to come in and do a review of shear and moment diagram. Again, this was actually a basic solid mechanics class. And when you're introducing shear and moment diagrams, everybody just draws a beam on the board. It was just like Tonya was saying, why would you draw a pipe or something simple on the board when there's things all around you? So that day I actually came into class on a skateboard, which was kind of scary for me, and you have to kind of make sure the room is okay. And if you're scared about this, you can have a student do it and let them see it. But, so you come in with a skateboard that day, and back to the comment about the first 5 minutes of class, that was my hook. So I got him, and then we talked about what kind of forces are in a skateboard, and have people broken a skateboard, and then we went through where is the forces the maximum in a skateboard. Well, how would you get that? Oh, we drew a shear and moment diagram. So we went ahead and drew one, and we started talking about, well, where does the maximum shear force come in? Where's the maximum bending moment and the bending stress, and how does this work out? And that discussion really got the students thinking, and then the question came up as we were doing this, was anybody ever broken a skateboard? And it turned out there were actually a couple students at that time that had broken skateboards. And so then the question, well, where did they break? And, well, why do you think that is? Well, here's where the force is. And then that morphed into more students asking questions about, well, so how much force can it really take? And how much force did it take to break it? And I said, you know what, we're going to cover that tomorrow. And so then I came back to the next class period, and I had just worked up it was kind of an extension of my real-life example then, and I went and figured out what the properties were. It turns out skateboards are made out of maple plywood usually, and so I got the modulus and the ultimate strength, and I could go through and worked out the example problem then of what kind of bending stress was in it. And then we talked about what kind of force it actually took to break the skateboard. And then, of course, they wanted to keep going. They actually asked more questions, and they said, well, wait a minute. I don't remember what the number of the value was, like 500 or 600 pounds that it took to break the skateboard. But, of course, this is a static class. I mean, it's a solid mechanic class, right? So we have mostly static things. And so then it led into a discussion where we actually put an impulse on there. And I said, I'm not really going to cover that here, but you're going to get to a dynamics class, and guess what? You'll actually start talking about that. So not only did I have them motivated in my class, but they were moving on and ready to start covering further classes. And the greatest part of this was it's like I didn't have to pull questions out of them. I didn't have to pick on any students. They were just volunteering, and they kept the class going, which is a great feeling from the front.
You can say that again. So that we've given some examples of using the everyday examples, and this is really supposed to be a discussion, so I'm hoping, folks, that you might come up with any questions you might have, any comments, any ideas. I can always start with a question that everybody wants to ask. So, Tonya and Scott, how much prep time does it take to incorporate everyday examples in your classes?
Well, you know, if you use the ones that are already available on the Engage website, it really doesn't take long. Sometimes it actually takes less work because it's fantastic. The developed E3s that have those 5 E's we talked about, explain, elaborate, explore, those are already set up for you. You've got your example, you have the solutions, you have example problems. I mean, it's unbelievable. You're done. It saves so much time. If you already have your lessons completed, typically you're really sort of just swapping out the E3 for some generic example you have. So maybe 20 minutes or so to look up, like Scott was saying, the proper material properties or whatnot. I will admit, I tried to be clever and I said, okay, I'm going to come up with my own E3s. I had some ideas, and so I actually had, you know, you can get from your campus police department, typically in the summertime, all the bikes that get abandoned on campus, if you ask them. So I got 8 bikes given to me, and with my Engage money, I had them sort of cut apart and mounted on plywood. So I have the pedals with the bike frame, I have the handlebars and just the stem mounted on a separate piece of plywood, and I use them for different things. But I'll tell you, that was a lot of effort, it was a lot of work, and they don't work as well for what I was hoping as the E3s on the website. So it was a lot of effort for a lot less bang. So start with what's on the website for sure.
If you pull the ones you already use, you can get the 6 or 8 that you need in a class. Again, not more than probably 15, 20 minutes for each one. So in a couple hours, you can have a whole semester's worth of E3s in your courses.
And then you've already set it up so that then you can use them in the future as well. That makes a lot of sense. Yeah. Another question is always about large classes, as people worry a lot about large classes. So do everyday examples work with large classes? What are some of the issues?
Well, I'm teaching a class that is 50 students right now, so that's not huge. I mean, it's not the 200 chemistry class scale, but it's still a big class. And as far as I'm concerned, I think it's the same. As I mentioned, because handing out the parts for the iPod cable, I just have my little baggie, and in the bag is the little baggies, and I know ahead of time how many seats there are in a row, so that really speeds up the handing out of stuff. You can still always, you know, if you can show a video, you can show pictures. I use a Mac, so it has the built-in camera like we're using now, and I just turn on FaceTime, and so if I want to demonstrate plain sections remain plain, I'll just put my beam up in front of the FaceTime camera and have that project on the screen, and then I have extra beams that I pass around the room that students can play with, and I walk up and down the aisles still demonstrating, but the first thing I'll do is put it up on the screen so everyone has a chance to see it close up, and I can still ask questions, have them think, pair, share, whatever.
Yeah, and all the benefits you get in a small class, you get in a large class also, and you become more approachable. It's easier to interact with the students even in the larger classes.
And we got a note from Krishna agreeing. He feels it works especially well with the large classes. But now Yao has a question. What's your question, Yao?
So Tonya was just talking about developing our own E3. I do have some ideas that I put down on the proposal that I submitted. So if I do go through that, I mean, do I have to submit it for approval before actually I do that?
Oh, no. We would love to have you share it with us. So the approval process is to get it up on the website.
Okay.
So if you, we'd love to have you share it with us in whatever ways you want, and we just go through a review process before it goes up on the website.
I see. Okay.
It's actually almost better to try them in the classroom, because now I know where the weaknesses are of mine, and I'm working on improving how I use them so that they actually become a little more effective.
And another point is, don't think you have to use exactly what's on the website. You kind of have to make them your own. You know, the skateboard example, they wanted something a little different, and so I went that way. You know, you have to make it something that you're comfortable in and you think they're in touch with, and so, you know, use the website examples as a basis, and then you can change things a little bit if you want to.
Absolutely. Thank you.
And actually, we'll talk about some other sources of everyday examples along with the website as well. And I think Tonya's point is a good one. If you are going to, if you're going to try it out with your class, because I know each time I try or pilot something, it gets better when I'm done with it. So we talked about it. No, I have to ask this one question, because as someone who the first time I went on a skateboard, I immediately fell off. When you're doing these kind of things, do you worry at all about making a fool of yourself?
No.
Actually,
Good.
making fool of yourself is kind of fun. And I mean, the biggest key to this whole thing is letting the students know what's going on. You know, the fact that, look, I'm trying to do something because I think I can do a better job teaching you, and they will appreciate that, and they're more than happy to go along with you. One of my favorite examples was the day that I was going to do pressure vessels, and I found the E3 that had cooking hot dogs, and I said, actually it was cooking sausages, and I thought hot dogs in the microwave worked better. There's the example of moving it on to something that I wanted to do that I thought would work easier. But so I rolled a microwave into class that day, the whole time thinking this was really ridiculous because they all had cooked hot dogs, and they knew that they split the long direction, and so I was going to go into an explanation of why the hoop stress is larger in a pressure vessel and things like that. And the whole time I thought it was just going to be ridiculous, and then I did it. And the funny thing is I had somebody in the first row who was really hungry and said, can I have the hot dog? And I'm like, well, sure, you can have the hot dog. Why not? So, you know, and I'm feeding them in class, and they thought that was all funny. And then after I got done with that lecture, I actually had a student come up to me after class and say, Professor, I just wanted to thank you for the lecture today. I mean, he actually went out of his way to say he appreciated the fact that I was just, you know, doing something a little different to hopefully help them to learn a little bit better and kind of remember what's going on. The other thing, we're going to get into retention and how that works, and you know, then the student comes back, and that student could later be working on a homework problem or something, and he'd come back and ask a question, and I could just say, remember the hot dog example? And oh yeah, and then they'll bring it right back, you know, so it helps them remember what's going on too.
And I think the other thing to point out is study after study shows that for a lot, especially our underrepresented students, a lot of the STEM, that a lot of times that having interpersonal rapport with the faculty is good for them. It actually helps their self-efficacy, and for some of the underrepresented students, that's really important for their own retention is their own self-efficacy, and that interpersonal rapport is huge. And there's nothing that builds interpersonal rapport like making a fool of yourself in front of the students.
Well, as Krishna says, it makes us human, which sometimes students don't get.
Yeah, Krishna's absolutely right.
So how about a little bit more about other everyday examples, other favorites that you have? Scott?
Well, I like doing I have a freshman physics class this semester, and I don't know if you're familiar with the Men in Black little video clip, which you can pull off YouTube. It takes, I don't know, 30 or 40 seconds to run, where the car actually drives upside down in the tunnel. And, you know, which is pretty ridiculous when you think about it, until you develop that a little bit further. And so you can show that clip, and there's your 30-second hook that gets everybody paying attention, and you can say, well, is this actually possible? And of course they just say no, and you say, well, are you sure? And you can kind of move from there and say, well, wait a minute, we have formula cars and Indy cars that have fins on the back. What are those for? Well, they induce drag, and that actually creates a downforce. And the truth is, then you can actually develop that, and that's kind of a fun one, because you can actually develop the speed now you need to go, so you actually could drive a car upside down if you had the right fin, and that's a fun one. The students really like that one.
And it also points another example, which is for the everyday examples, you don't always have to have the specific thing there. You didn't bring a car in and try to make it go along the ceiling of the classroom, although that could have been interesting. That video, and particularly YouTube, is just a marvelous source of really short video clips that you can use. Tonya, how about you?
Well, you know, and building on that, I have down railroad lines for thermal expansion, but, you know, and I do have pictures of that, but even before that, I use the students' own personal experience by having them close their eyes, and I'll say to them, okay, you're driving over a bridge. Who's driven over a bridge? I'll raise their hands. Okay, you're driving over a bridge, close your eyes. This is the sound you hear. Ba-boom, ba-boom, you know, and what's the ba-boom? And they're like, oh, those are the expansion joints. Oh, why do we need those? You know, and we talk about why they're there, and then we talk about railroad lines, and you can find fantastic pictures online, and especially look for things in Britain, search BBC, because a few years back they had a heat wave, and ton of their railroad lines buckled, and one of them links to this horrible story, oh, say it isn't so, where a Guinness truck, a train full of Guinness derailed on its way to London. It was, you know, turmoil. So, you know, so it's a little fun, and you bring that in. And then the other one I really like is brake calipers on the bicycle for friction. And I just ride my bike in that day, so I have it here on campus, but you know, you can always just grab a student's bike. There's enough of them around, and literally have the bike in class, spin the wheel, grab the brake lever, and you see the brake stop, and we look at how it's set up, and then you can find all over on images on Google just a schematic of what the system looks like, and then you can say, okay, well, if I pull on the lever with this force, I get this much tension in the cable, and that results in, you know, what force on the actual brake pads themselves, and then you can solve a friction problem. And it's a lot better than, oh, I have a wedge sliding up the hill, you know. So it works really well.
But as you said, sometimes things don't work, and that may not be a bad thing. And this is, I think, my favorite slide for the entire slideshow, because that is indeed Tonya climbing up the mountain, or the rock. So,
well, it's the rock. It's Cassiopeia on Sonora Pass Highway, but whatever.
So how about talk a little bit about your failures and what you learned from them?
Well, the reason this picture got put in was it was a dramatic failure, not the climb. That was an on-site. But so with friction, in rock climbing, a lot of the protection that you use to, if I were to fall, and right now I think I have gear at my feet, so I'd probably only fall 4 or 5 feet at that point. But if I fall, the piece that's holding me to the rock is purely working on friction. So I had thought, oh, instead of the bike brakes, climbing has become really popular. I'll show this fun climbing video that shows people placing gear and then falling on it. And I'll start at the beginning of class, and then I'll have the gear with me, and I built a little faux wooden crack, and we'll show how it works. And the thing is, yeah, it was cool. They were engaged. Some of them were terrified, just the thought of that. And it didn't work as well as I would have liked it to. And so there's a difference between something that's cool and something they're familiar with. And it was that familiarity that makes an E3 so successful. So I might still show the video for the cool thing, but I'm going to use the bike as the actual E3, because they've all ridden a bike. They're all familiar with that, and that works much better for friction. So it's not just about cool, it's about familiar.
And Scott, you learned some things from failure as well.
I did, and one of the major things I found out was the other thing when you're developing these, and you're giving them a problem to work off of that's your hook, and the hook is good, but you also have to come up with a problem that they want to know the answer to. I came in with a wine bottle problem one time, and it was a twist-off top on a bottle, and we were looking at the stress and trying to figure out what kind of torque we'd need to get the top off a bottle. And of course, they all thought it was fun. I brought in sparkling grape juice and held it up in front of the class, and they all chuckled and thought that part was fun. And so I hooked them, and that was fine. But the truth is, they really didn't care how much torque it took. It didn't matter to them. They all knew they could twist the top off a bottle, and so the class kind of fell flat. I hooked them in the beginning, and then I just kind of lost them because they really didn't want to know the answer. I think that's kind of another key thing you want to include is the problem has to be something they want to know the answer to.
That makes a lot of sense. But I know when we were talking about this earlier, you both were concerned about the whole idea of the negativity of failure, whereas as engineers, failure is often a positive.
Yeah, it is kind of ironic. Over the last year, we've completely revamped our first-year engineering course. I've been working with a colleague and completely gutting it and starting over. And one of the things that's been sort of a big talking point for us is that we want activities where the students try, fail, retry, that sort of thing, because we feel like this generation comes in thinking they have to know the one right answer. Failure is a terrible thing. And that's really, as you said, Pat, not what engineering's about. But it's ironic that I can be afraid to go into the classroom and try these things because I don't want it to fail, as opposed to remembering the students appreciate anything I'm trying, and they'll let me know if it doesn't work, and then I just build on it and make it better. And so I'm not going to have cool E3s if I don't try.
Mm-hmm.
And besides that, there is something really fine about failing in front of them, to letting them know that it is okay and you can come back from that. And you get to the upper level classes now. Matter of fact, yesterday afternoon, I'm in charge of doing capstone this semester, and we're building a formula car, and we went out and bent one of the control arms the first time they locked up the brakes because we didn't have the forces right. And it's like, these are seniors, and some of them just get terrified. And it's like, it's okay, we can fix this. We move on. This is part of engineering. And I'm not sure they realize that, because especially, in the freshman and sophomore level classes, we have these very well-formulated problems, and we're going to lead them right to the one correct answer. But, life doesn't work that way. And us failing, I think, is a fine thing to show them.
Well, and failure may be like getting the mumps. If you get used to it early and deal with it, you're in a whole lot better shape than if it happens when you're older. So, all right, so we really actually do have some rules for selecting everyday examples. That they are familiar to your students, that they are interesting and fun or relevant, that they pose a question that students want to know the answer, that they demonstrate a concept that students have trouble understanding. And Tonya, do you want to talk a little bit about that?
Well, I just, when you don't have a lot of time, which none of us really do, and you're trying to figure out what topics to use E3s for, I put a number of E3s in my mechanics and materials class, and I have data on how the students had done pre-using them on exam problems and then post-using the E3s. And I found that in those areas, I use the skateboard, love the skateboard for sure, moment diagrams, but it definitely engages the students more and it makes it more fun to teach. But the students had already been doing pretty well on exams and were averaging at about 80%. So I didn't see a big jump in student performance on exam problems. So I didn't get a lot of bang for my buck on that as far as student learning. But I did for engagement and retention of material. But for the iPod example, my students were, the numbers on this screen, averaging about 53% on exam problems, and this was typically the final exam, and of course this is taught week 2 of the class.
Right.
After E3s, they're up at about 78%.
Wow.
And so, yeah, so go for those topics they don't do well in first so that you get overall better learning, would be my idea.
That makes a lot of sense. And the other ones we were talking about was engaging students quickly and keeping them interested. And then finally, don't require a lot of equipment or prep time for you. And that reminds me of something that came up on Tuesday's discussion, the scavenger hunts.
Mm-hmm.
I know you do a scavenger hunt, Tonya, and one of Jennifer Love from Northeastern does scavenger hunts too, and that seemed like such an exciting way to get a lazy person's everyday examples.
Yeah, it's great. You literally can make it an assignment. Mine started in statics when I wanted the students to see real-world examples of a pin, a roller, a fixed connection. So they have an assignment where they go out in teams and they have to take photos of a real-life pin, roller, and fixed connection and then draw the FBD of it and discuss it. So the same thing, if you want everyday examples of a beam and bending so that you can draw moment diagrams, make it an assignment. Let them go out and look for them in everyday locations, and you'll be so surprised what they come up with. I mean, they were using laptop covers and photocopier covers, the lids, the connection as their pins, because those are pins. Brilliant. I wouldn't have thought of that.
And I know that Jennifer said that she has them take pictures, and then she can use the pictures herself the following year.
Yep.
And going back to our comments about failure, Krishna has a really good point that, and I think we indicated, but I think it's really important to be explicit about it. It's not just telling them it's okay to fail, but that from the failure is when you get up and then achieve success, and that's really what's in the key. It's so the concept of failure is we all fail at times, but then we can learn from it, build from it, and move on from there. And I think that was a really important point for Krishna to bring up. So you're recommending scavenger hunts. So Scott, I know you haven't done scavenger hunts in the past. You're planning to do it in the future.
I haven't done, but I may now.
All right. So one of the things about everyday examples that we keep talking about and almost harping on is that they are familiar to your students. And I think one of the things that's important for us to remember that those things that we think are familiar to our students may not actually be familiar to our students. I don't know how many of you are familiar with the Beloit mindset list. It's every year the folks at Beloit College pull together what's familiar to that year's entering class. And there were some things here that I thought were really fascinating. These were just some things that I thought were interesting, and there's a long list. One of the things I find fascinating is for the class of 2016, women have always piloted warplanes and space shuttles. And indeed, except for people who've been paying attention in the last couple of months, women were always Secretary of States in the United States for their lifetimes. They've always lived in cyberspace. And if they miss the Daily Show, they can always get their news on YouTube. And I like that actually because I watch the Daily Show for my news too. So whether it's the Beloit mindset list or other ways, it's important for us to actually understand that what's familiar to us may not be familiar to them and vice versa. Now, I know, Scott and Tonya, one of the things you always say is when I say, well, how do you know if it's familiar to students? How do you find that out? You two can say it in unison because you always yell at me and say that.
Go ask the students.
Yes, yeah. Yeah, I mean, I think that's really at the core, that ask the students. And I love with your scavenger hunt idea, which means that not only do you ask the students, but have them go out and find things, and then you know for sure that it's familiar to them. So we've been talking a lot about everyday examples, but one of the things I wanted to make sure is we just spent a little bit of time on the research, because we're all very enthusiastic everyday example people, but it's important to know that this does come under a research base. And certainly what we found in the research is that using everyday examples increases the likelihood that students will be interested in the information that they're learning, that they will better retain the information that they learn, and interestingly, that they more highly evaluate the quality of the course when they have the everyday examples in it. And I know, Tonya, you've done some work on looking at how well they retain the information, comparing students with having the everyday example and students who didn't.
Yeah, this is a brief snapshot. Once I learned about E3s, what I did is so I teach both mechanical and civil engineering students their mechanics and materials course. And so all of the mechanical engineering juniors here at Santa Clara University then take a junior design. Junior design starts winter quarter of their junior year. They take strength and materials winter or spring quarter of their sophomore year. So there's definitely at least 6 months or so between the end of when they take strength and materials and when they start junior design. And I worked with the professor of that class, and he gave me 15 whole minutes of his very first day of class. So this is coming back, from Christmas break. And so I put together a short quiz. I made it multiple choice just because of the shortness of time, but still it was conceptual questions, and I had conceptual questions on that would basically demonstrate their learning from the iPod cable, and also shear and moment diagrams. And I have one other question, and I'm blanking on what that was at this moment. But I had data for both the composite material axially loaded member, which is the iPod cable, and shear and moment diagrams. And what was really interesting is basically students who were taught without the E3s, when I checked retention of their concept, and this was with no time to review or prep, 46% of them got the moment and shear diagram question right, and 71% got the composite axial. But once they'd had E3s, the retention on moment diagrams jumped to 61%, so a 15% increase, and the composite axial loaded jumped to 85%, so a 14% increase there, but up to 85% retention. And so that was pretty exciting.
And that was 2 3/4 later. That's just really fabulous.
With no review, a ton of them came to me afterwards. They're like, Dr. T, we're so sorry, I didn't know the answer. If I had just had a couple days to review. I was like, I don't care, don't worry about it.
I wanted to know what you knew without review. Yeah.
Exactly.
Now, one of the things we've also found in the research too is that if you use several everyday examples, those will work well. But if you're really going to try to change like students' grades and have that kind of an impact, you really do need to use a lot of them. And we have found with a couple of cases where the class became primarily everyday example based, that almost all the concepts were demonstrated using everyday examples, that there was an increase in grades, in course grades. So there is research, and we have summaries of the research on the website, and we've actually written some papers and had publications, and send me an email, and I'll be happy to send things to you. But I'm from Massachusetts, and so I always quote Tip O'Neill, and Tip O'Neill always used to say, all politics are local. So for me, all data are local. So we found that telling people about the research is great, but when you're talking to your faculty, they want to know, will it work here? Does it work here? And so there are some ways to think about what you can find out, how well it's working here. And my philosophy is, don't set up another survey. Take a look at what you're already doing and see what you can use. So that, for example, if you're interested, everybody has course evaluations, and you've been taking course evaluations for a while. So look at the course evaluations and look at some of the questions that you think might make a difference. Questions about interest, overall course assessment, and you can use that data from the classes that you taught before you started implementing the everyday examples and look to see a change over time. Similarly, take items from the current tests. If you've used similar items, see the response to test items for the things that you were using everyday examples with, and then see if more students get the answers correct after you started using everyday examples than before. A good pedagogical technique is kind of doing in-class assessments. At the end, give a quick 2-minute concept quiz at the end of a lesson and see, are they picking it up with the everyday example? That's also a good way to deal with what's going on in your class. I mean, it gives you very nice feedback as well. And if you're seriously interested in this and you would like to have some kind of measures that are specific for you, send me an email. I am the measurement, assessment, evaluation, and research methods person, so I'm happy to work with you to figure out what might be a nice way of looking at what's happening with the everyday examples. And if you want to do it, and who knows, we could do a panel at ASEE in the next year or so, talking about what the impact has been on a variety of classes. So we've been talking a lot. Just wanted to make sure if anybody had any comments, questions, before we start talking a little bit about sources of everyday examples. Okay, Krishna, you have a question.
Yeah, I just wanted to agree about this assessment. I think, you know, maybe part of this ENGAGE project, I think you should probably give ways to have people assess this as a thing, because, you know, I see a big, how do you say this, negativity in the faculty when somebody wants to try new things. Because they say, how do you know it works? I mean, for them I say, well, unless you try, you don't know. So what I think they are hinting at is there any research done? And sometimes things like this are not there in the literature sometimes. So I think we have to get more support to share, to tell those people that, you know, what we are trying to do is the right route. It's just that we don't know the impact immediately.
I think that's a really good point, and that's part of the reason why I strongly encourage anyone who would like to do any assessment to please be in touch with me to see if there are things we can do to help. One thing I do think we need to remember is often the first time you do something, you're not fabulous at it. There is a little bit of a learning curve. And that needs to be taken into account when we're doing the assessment. Although one of the nice things about everyday examples is they are easy enough to use that it's not as difficult as if you're changing your instructional strategy or changing your curriculum, where that is a lot of work and there's a lot of learning time. Whereas, and I'd be curious, Tonya and Scott, about your points about this. Implementing everyday examples, how hard was it when you first started?
It was too easy, actually. Because actually, you know, I had a solid mechanics class already done. I'd taught it the semester before, and you know, done okay with it. And then actually, when Ian Patterson approached me and said, "Are you willing to try this in your class?" and I said, "Yeah, that looks like it all made sense to me," and it does. And you know, so I spent my 20 minutes for each one, and basically just took out, you know, Tonya's impregnated beam of steel with copper, which doesn't make any sense to anybody. And I just took that out and threw the iPod example in, which took me 15 minutes, and away I went. So it was real easy to get started. And you know, there were a couple failures, but the other thing is I let my students in that class know exactly what I was doing. You know, I said somebody showed me this new way of doing things, and so I'm going to try it out with this class. And I told them that, you know, almost from day one, that this was what I was going to be doing, and they really kind of got on board with me.
Yeah, I think it was really easy too. You know, it's almost an engineering criminal not to have a demo or a picture or some sort of real-world application, because everything we do has a real-world application.
Right.
So why not pick something the students are already familiar with? You know, it makes a whole lot more sense than me trying to go into a building and find just the right column and say this has these multiple axial loads on it, when they may or may not have seen a building skeleton. And later on, for the civils, that will become something they're familiar with, but it's not yet, so it's a little intimidating. So pick something real.
Those are really good points. Now, Farias asks if the Kolb model is the underlying framework from which the positive impact of everyday examples stems. Now, Tonya, I know the Kolb model is one that you've used.
I actually don't use the Kolb model of learning styles. I actually use Richard P. Felder's.
Oh, that's right. It's Ian who used Kolb. Sorry.
It's not Richard P. It's Richard. What is his middle? Whatever. It's Richard.
Richard
Felder. Yeah. Sorry, it's Richard P. Feynman, the physicist. But so I use Richard Felder's, and that's one of the reasons I have been having my students do Rich's learning style assessment since I learned about them back in 2000. And I actually make my students do it every quarter at the beginning of the quarter, so I know what their learning styles are, and they know what their learning styles are. And I have found when I do this with engineering students, it is the rarest class that I have more than 10% of the students having a strong tendency towards verbal learning. I always have 90% or more that are visual learners, and that's really key because written work, spoken words, that's all verbal. So having a demo, having a picture, having a visual that they can attach to it is so key to their understanding. Also, a lot of them are active and they're sensory, and so again, that sensory learners, having that is really, really critical. Usually the majority are sensory. So I really found when I learned about the E3s, I was so excited because I had been trying my own demos, but they weren't always every day. They were an application, but they weren't everyday applications that were much more familiar to students. So this was just, I thought, just tied right into what I knew about how my students learn.
And also, I think it's important that the concepts of everyday examples come from a variety of frameworks. It's certainly, the Kolb is one of them, but then also part of what it is about what we know about cognition, and what we know about cognition, and when concepts are introduced using demonstrations that are familiar to the student, that actually helps them get more cognitively deeper into that which is being developed. Now, on the other hand, when you use unfamiliar examples, it actually pulls them back so that the brain power that they would be using to try to understand starts panicking a little bit because they're trying to understand the example as opposed to try to understand the concepts behind it. And so I think we're pulling on a lot of different learning styles here, but we're also pulling on some issues about cognition as well. So I think it's nice to know that Everyday Examples is drawing on so many different things to have an impact.
You know, I just want to throw this out. When I was in graduate school and taking continuum mechanics, the professor was doing this example in 2 dimensions, and I was lost. And I asked him a question. It's like, I don't understand where you're going with this. Let me ask these questions. Like, no. Here, let me just re-explain it to you in 3 dimensions. Why are you making it even harder when I'm struggling with the easier one? And that's sort of how I feel about when we take these unfamiliar examples. It's the same sort of thing.
Yeah, I think that's right. Well, we've only got a couple of minutes left. So what I would like to do is just give you some ideas of other sources of everyday examples that one that you all are familiar with because you wrote about it in your mini grants, of course, is the website at engageengineering.org. You'll be pleased to know, and we have hundreds of examples there, you'll be pleased to know there is a new addition to the website, and I think you'll probably be getting copies of it as well. We now have postcards of some of the everyday examples, and we're using that to encourage people to develop everyday examples, but also to make people aware. So here are some of the postcards, and then this was one of my favorites because it's got, I'm not sure how, it's got catapults, and one of our everyday example gurus, Laura Bottomley, with a chain of paper clips. And then, in fact, we spoke about David's shaking dog. David and his graduate student, Andrew, are part of our postcards. And I think probably the most important thing is, at some point, think about it and see down here at the bottom, you could have your very own engaged postcard. So let me know, or just let me know if you would like some of the postcards, and we'll be happy to send you a pack of postcards. So, and they're fun ways, you know, they're just fun ways to get people thinking about it. Also, Pete, we've spoken about Ian Patterson, and Ian was the man who got Scott first involved with Everyday Examples. Mm-hmm. Ian has developed 3 booklets of 12 everyday examples each, which are very well thought out and really fun and interesting. And obviously, one's in solids, one's in dynamics, one's in fluid mechanics, and one's in thermo. And those you can download through engineeringexamples.org. Well, while they're everyday examples, there are also a lot of simulations that you can use to kind of develop your own everyday examples or to supplement what we already have. In Colorado I love it. We've been very skateboard oriented lately, so I picked one of their, the Skateboard Energy Park. But they have hundreds of different simulations that will use kind of fun along with everyday examples to demonstrate concepts. My second favorite one is John Travolta, which looks at static electricity. And then, too bad it's not around Valentine's Day, because we have radioactive dating. So think about going to their website and see if there are some simulations that you can use along with some of our everyday examples, or that to develop your own. And then if you want to just go for video, this is a horrible, horrible URL. You'll never be able to find it. But if you just Google on Professor Walter Lewin, or Walter Lewin, MIT, he's got a series of 34 lectures. And my favorite is when he's the pendulum, as you can see in that little picture. If you don't want to be the pendulum for your class, which I can certainly understand, but you want people to be paying attention, using his videos, and you know, he's got the whole lecture, which you're probably not going to want to use, but you can just clip out the part where he does the demonstrations with the ladders and with the basketball and as a pendulum, and use those for everyday examples as well. And if you find other sources, because there are lots of sources in lots of places, that we would be delighted to hear where you found sources and what you found. So we're really grateful for your being here. We've got just about a minute left. So be in touch with us. And one thing that Susan Metz, our PI, reminded me is we are going to be having a meeting, a lunch meeting of all the engaged people, particularly the mini-grant folks, particularly you and our other colleagues from the Everyday Examples, at ASEE. It's going to be, so June 23rd, there will be a lunch someplace in Atlanta, our treat, so that we hope that you'll be joining us for it. We'll give you more details when we have more details. And so we can talk about what we're doing and what we're learning and things like that. Also, if you're going to be at ASEE anyway, please feel free to come to our session on spatial visualization skills, which is going to be on the 24th at 12:30. So any last-second comments, Tonya or Scott?
I would just say have fun with it, be fearless, enjoy. You know, it's a lot of fun.
Yeah, these really do make teaching class a whole lot more fun.
So thank you all. We're very glad that you were here. and we look forward to meeting you all in person in June and hearing much more about what you're doing. Thank you, and have a good rest of your day. And I'm off to Cambridge to go to a birthday dinner. Thank you.
Eat well.